When a ship moves through water, it creates a V-shaped wake on the surface. This phenomenon is a classic example of wave mechanics and fluid dynamics, specifically governed by the Kelvin wake pattern. How the V-shape is created. As a ship moves, it displaces water, creating a series of waves. These waves are not random, they form a distinct and predictable pattern due to the interaction of two types of waves. Transverse waves. These are waves that run perpendicular to the direction of the ship's movement, forming crests and troughs that are parallel to the boat. Diverging waves. These waves spread out behind the boat at an angle, moving away from the ship's path. The visible V-shape is the result of the superposition or interference of these two wave systems. The crests of the transverse and diverging waves intersect, reinforcing each other to create the prominent observable V pattern. The angle of this V-shape is remarkably constant. Lord Kelvin, William Thomson, a 19th century physicist, discovered that regardless of the ship's speed, as long as it's moving faster than the minimum wave speed, the angle of the wake is always approximately 39 degrees, more precisely 19.47 degrees on either side of the ship's path. This is because only waves within this specific angular range can travel at the same speed as the ship, and thus constructively interfere to form the stable wake. Factors that influence the wake. While the angle is constant, the appearance of the wake can vary based on several factors. Ship speed. A faster ship creates a longer and more energetic wake. Hull shape. The design of the ship's hull affects how it displaces water, influencing the size and intensity of the wake. Water depth. The Kelvin wake pattern holds true for deep water. In shallow water, the wave pattern can change significantly as the waves interact with the seabed. This phenomenon, known as solitons, can even lead to the boat's own waves pushing it forward, a phenomenon called wave riding. Fluid viscosity. The viscosity or thickness of the water can slightly affect how the waves form and dissipate. This V-shaped wake isn't just a cool sight, it's a direct result of the energy a ship expends to move. A significant portion of the energy used to propel a ship is lost in the form of these waves, a concept known as wave-making resistance, which is a major component of the drag a vessel experiences.